Okay, so here we have another question from the November 2023. That was a question 9 for the paper 1 of the MAA SL, but that automatically means that it will appear on the HL paper as well, just with different numbering, perhaps in a question 3 or question 4 or question 2. Here I'm going to tackle only the part A. That given the rational function that we have here, it will ask us to show that. Show that means your answer is given, therefore the 4 marks you see here, they will be awarded for showing kind of like, the steps along the way. Now here we have a rational function, like I said before, rational function, which means to find the derivative, we're gonna have to use the quotient rule. Quotient rule will always works, right, with rational functions. You could perhaps use the product rule too, but I would rather go with the quotient rule. That's going to give you an opportunity to remind you as well what the quotient rule says about. So the quotient rule says when you have a function, a rational function which is in the form f over g of x, and you want to find the derivative, that would become the derivative of the top times by the bottom, take away the top times by the derivative of the bottom over the derivative over the function of the bottom squared. So let's pick up our function here, which is the f of x, which is equal to 12x over the x squared plus 2 and all of that to the power of 3. And we want to find the derivative, so let's just change color and make it with black. So the derivative of that function is going to become, as we said, based on the quotient rule that I've written up here, it's going to end up with the derivative of the top, which is 12x derivative, times by x squared plus 2 to the power of 3 minus the 12x times by x squared plus 2 to the power of 3, and all of that derivative over x squared plus 2 to the power of 3, and all of that squared. No derivative is involved at the denominator. Now let's calculate individual derivatives. We have the 12x derivative, that's going to give you just a 12. However, that derivative here, which is x squared plus 2 to the power of 3, and all of that derivative, that will mean that we're going to have to use the power rule, and that's what I'm going to use now. 3 times x squared plus 2 to the power of 2 times by x squared plus 2 derivative, and that is when I applied the chain rule. So all in all, that's going to become 3 times by x squared plus 2 squared times by 2x, which is the derivative at the end. So continue with my differentiation here. That's going to give me 12 times by x squared plus 2 to the power of 3 minus 12x times by whatever I have up here, which altogether is going to be 6x, and then times by x squared plus 2 and all of that to the power of 2 over x squared plus 2 to the power of 6. Now, I need to check what my answer is and try to sort of kind of like modify. I can see that the denominator has to become to the power of 4 and to the power of 6. So what I can do, I can cross the x plus 2 to the power of 2 from that side and that from that side, and then cross that x and make it into a 4, and that will match with what I need. So I'm going to end up with x squared plus 2 to the power of 4, and then at the top, if I combine those two together, I'm going to end up with 12x squared plus 24 minus 12x times by 6x, and that's it. it's kind of weird now because I'm going to have to make the numerator as 12 and then 2 minus 5x squared. So where is this gonna come from? I'm gonna have to work with the numerator a little bit. There could have been different ways to go faster, but like in reality, even if I do an extra step, all I want is just to make it match with the show that command that you can see up there. So the 24 is on its own, it's gonna stay as 24, and then I have 12x and 6x, that's going to give me 72x squared. So 12 minus 72x squared, that's going to give me minus 60x squared. And now you kind of tell where is this coming from, because if I factor out the 12, that goes 5 times into 60, and 2 into the 24, I'm going to end up with 12 times 2 minus 5x squared over x squared plus 2 to the power of 4. And that's QED, which means has been demonstrated. And that's the end of it. Another cool way perhaps to do that would have been to factor the 12 from here, from that stage. So if you factor out the 12 from here and the 12 from here, because I know that that's part of the answer, that's going to become 12. And then that's going to give me with x squared plus 2, and then minus 6x squared, because I have the x from here and the 6x from here, and that's going to become 12 times 2 minus 5x squared. So that would have been a little bit faster, of course keeping the same denominator in both cases, but in reality the only thing you need to do is, because just show that function, to make sure that your final answer matches exactly with what you've been asked to do.